Our rule for osmosis is that salt sucks. Anywhere you have an area that is saltier or sugarier, anywhere there's an area that has more of the solute, that area is going to pull water towards it. Okay, so that rule is going to be good all the time if we're talking about osmosis. And it is how you are going to predict where the water is going to move. Okay, so for example, if I have a cell sitting in a solution and the area outside of the cell has more salt, then the water is going to move towards that salt and be sucked out of the cell. Now, when we have these situations, we use some words for these solutions to explain how they relate to one another. It is kind of silly, but it does help to be able to predict where this water is going to move. I'm going to come back to this. Okay, so your three types of solutions. The first one, these are already on there for you. Just follow with me. The first one's called isotonic, and it means the solution inside the cell is the same as the solution outside of the cell. Okay, and a lot of these you'll see a cell kind of in a beaker, or you'll see the tube that I just skipped past. We'll go back to that. But when those two solutions are the same, the water is basically going to move in both directions. So you would not expect any big changes. Okay, water's going to move both directions. That's called isotonic, iso meaning the same. That one's easy. Okay, but that's not always the case. So sometimes we see solutions where there is less solute. So hypo means less, or you can think of hypo as low. But instead of just writing less or low, I also want you to write the word solute, because that's really what we're talking about. The solute of the solution is less. Okay? So you've got a picture of a 20% solution inside the cell and 10% solution outside the cell. Which one's less, 20 or 10?
10.
10. So the solution outside of the cell is considered hypotonic. Now, if you just took a look at that beaker and you said hypotonic, that doesn't tell me enough information. You have to tell me, are you talking about the solution inside of the cell or the solution inside of the beaker? And that's going to be really important in this week's labs. Be careful, just trying to throw those words out there and hope that you're right. You need to be describing where you're talking about. So in this case, I'm going to use my rule, salt sucks. The salt is saltier inside the cell, and so I would expect the water to move inside of the cell. When that happens, the cell is going to swell and maybe even burst. Yes, ma'am?
Why does it matter that it's equal?
It doesn't matter that it's equal, except water is going to move in or out until it is equal. And that's because of what we just talked about with diffusion. If there's any time that there's an area that's more concentrated than another area, the molecules will move until everything is at equilibrium. So do you understand Joy's question? She's saying, well, who cares? Who cares that it's saltier in here than out here? You're right, I don't care either. But the water cares. The water wants to have even solutions inside and out of the cell. That's a great question. So in a hypotonic solution, you would expect the water to move into the cell, and the cell would get bigger, and maybe even so big that it would burst. Whoa, baby. Okay? And if you can imagine, I would not enjoy that if that happened to me, but it happens to plants all the time. So that's hypotonic solution. Okay? If you flip your page, your last solution is called hypertonic. Now this one's easy to remember because hyperactive means you have more energy. So a hypertonic solution means it has more solute. Again, please don't just write more solute. More solute. Then again, the water is going to move to wherever it is saltier. So in this case, if the solution outside the cell is saltier, means it has more solute, it is hypertonic. We would expect salt to suck, and the water is going to move out of the cell. If the water moves out of the cell will shrink and eventually could die. We see this all the time with plants and they're wilting. Okay, lettuce from the grocery store. So you put it in the fridge, you leave it there for a couple days, it looks pathetic, and it is just wilting. It's because the water has moved out of those cells because there wasn't any moisture in the air. So it moved out to try to balance and evenly spread out. So it's possible that your plants would wilt, but then eventually die if the solution that they're in is hypertonic, which means, again, we're not always thinking about salt, but that's kind of the example that we use. But it could be sugar. It could just be not, if there isn't water, the water would move out of the cell to try to balance that out. And that's hypertonic. Okay, so let's go back to the one that I skipped and talk about something called a U-tube. A U-tube is cute. A U-tube is just basically, instead of having a cell in a beaker, it's showcasing two solutions, and then it has a line in the middle, and that line is representing the cell membrane. You don't have a picture of this, just follow with me. The line is showing what a cell membrane would act like. Okay? So what do you notice right off the bat of these two solutions? Okay? They are kind of the same level. Okay? They have the same amount, and this one has more what? Solute. Okay? Whether it's salt or sugar or whatever. More solute than this side. Okay, good. And I also want you to notice a lot of times in these pictures, they'll tell you what is able to move across the membrane. In this case, this arrow is telling you water is able to move across the membrane. Okay? So water is able to move across the membrane. The salt does not in this example. Okay? And so, based on our rules, if there's more salt over here, we would expect salt sucks, and the water is going to move from this side to this side. How can I tell that that is what has happened over here? Okay, the water on the right side is more, and this water is less. That's one indication I can tell that the water is what has moved across. Okay, has anything else changed? Okay, if you count them, there really is not more. So there's 6 here, and 6 here, and some here, and some here. They haven't changed, but they look a little different. Why do you think that is? Why do these look different? They're more spread out. That's exactly right. They're more spread out. And these are kind of more together. So this is just another way to show the water has moved and to show what the solute will look like when the water does. So when the water moves, this looks kind of like the same concentration as this. Now it's not in a percentage, but you could guess that that's what it looks like. That now it is evenly spread out, and both of those solutions have the same concentration. Okay, last slide. So for hypertonic, you should have, that means that more solute, and when water leaves the cell will shrink or die. Plants will wilt. Thank you, Harley. And then underneath, just to recap those two that we've talked about, diffusion and osmosis, it says diffusion and osmosis are both types of, and I want you to fill in, passive transport. Passive transport. What does passive mean? It has to pass. Okay? What else does it might mean? Have you ever heard the phrase passive aggressive?
Yeah, it means that you're like, passive aggressive is where you're mean but not physical.
Right. So you're not exerting a whole lot of energy. You might just be being sarcastic or being aggressive with your words, but you're not going to bust somebody up for real. And so passive just means it's happening, but it doesn't require energy. Okay? So the cell has not used any energy for either of those processes that happen. And we have one more type of passive transport to talk about. And transport's a weird word, but it means moving across the membrane. Okay? So for diffusion and osmosis, you have another blank. You may want to just recap what that means. High concentration to low concentration. And that osmosis is the diffusion of water.